Objective 9, know why transition metals don't form true noble gas configurations and be able to draw the configuration for an ion of a transition metal given its oxidation number. So the big thing you have to realize with transition metals is they are filling up the d orbital in the outer energy level. And that's unusual because noble gases are filling up the d orbital for one level below. Remember, you get to 4s, you fill up 4s1, 4s2, and then you go back to 3d. And then you go over and fill up 4p1 up to 4p6, and then you have argon, or I'm sorry, krypton, and it's got a full d orbital, but it's for the third floor, and it's the fourth is the outer level. But with transition metals, they lose electrons, and now the d orbital is in the outer energy level. But the bottom line is it doesn't really matter. In fact, it's a good thing because it gives transition metals a lot more options. So if we look at iron, iron is number 26. It's in period 4, so its noble gas is argon. First 3 floors are full. 18 electrons are set. So then it fills up the 4s, takes 2 electrons. That leaves 6 more for in the 3d. And that's what an iron atom looks like, is argon 4s2 3d6. And as you look at that, you should know that that has 2 valence electrons. And even though it's got the 3d6, right now the only valence electrons are the ones on the 4th floor, the 4s2. But when it loses those, so let's copy this down here. If it becomes Fe2 plus, that means it's lost these 2 valence electrons. So I could either put 4s0 or just leave the, take the 4s out. But now it's become argon 3d6 with a 2 plus charge. And it's like, well, that doesn't look like it normally does. You're right, it doesn't, but the 3d6 doesn't matter because it's still got a full S and a full P in the third shell. So that's what matters is, do you have S2P6? That's the 8 is great. So what happens when it becomes iron 3 plus? Well, now I've got my iron atom. I can lose 2 electrons from here, and this is the cool thing about transition metals. I can go ahead and take an electron out of that d orbital. So what? It wasn't full. In fact, now it's half full, so even better. So transition elements can add to the d orbital or lose from the d orbital, but they're going to lose the 2 valence electrons from the s orbital first.